Welcome to this lesson on Dalton's law of partial pressures. This fundamental principle in gas chemistry helps us understand how different gases behave when they are mixed together in a container. Named after the English chemist John Dalton, this law is essential for understanding gas mixtures in various real-world applications, from scuba diving to industrial processes. Dalton's law states that the total pressure of a gas mixture equals the sum of partial pressures of each individual gas component. In simpler terms, when you have multiple gases in one container, each gas contributes to the overall pressure independently. The total pressure you measure is simply the addition of all these individual contributions. This is a powerful concept because it tells us that gases in a mixture don't interfere with each other's pressure contributions. Mathematically, we express Dalton's law as P total equals P1 plus P2 plus P3 and so on. Here, P total represents the total pressure of the gas mixture, while P1, P2, and P3 represent the partial pressures of individual gases. Each P with a subscript identifies a different gas in the mixture. The beauty of this formula is its simplicity. You just add up all the individual pressures to get the total pressure. Think of partial pressures like building blocks stacked side by side. Each colored section represents the partial pressure contribution of a different gas in the mixture. Gas 1 contributes P1, gas 2 contributes P2, gas 3 contributes P3, and gas 4 contributes P4. When you add all these sections together, you get the complete picture, the total pressure. This additive nature is what makes Dalton's law so useful in practical calculations. But what exactly is partial pressure? Partial pressure is the pressure that a single gas in a mixture would exert if it occupied the entire volume alone at the same temperature. Imagine removing all other gases and leaving just one gas in the container. The pressure it would create is its partial pressure. This concept is crucial because it allows us to treat each gas in a mixture independently, making complex problems much easier to solve. Let's work through a practical example to see Dalton's law in action. Suppose we have a container that holds 3 different gases. Nitrogen has a partial pressure of 2 atmospheres, oxygen has a partial pressure of 3 atmospheres, and carbon dioxide has a partial pressure of 1 atmosphere. Our question is straightforward. What is the total pressure inside this container? This is exactly the type of problem Dalton's law helps us solve quickly and easily. To find the total pressure, we apply Dalton's law directly. P total equals the partial pressure of nitrogen plus the partial pressure of oxygen plus the partial pressure of carbon dioxide. Substituting our values, we get P total equals 2 plus 3 plus 1. When we add these numbers together, we find that P total equals 6 atmospheres. Notice how straightforward this calculation is. We simply added the individual pressures. This is the power of Dalton's law in action. Let's review the key points about Dalton's law. First, gases in a mixture behave independently. One gas doesn't affect another's pressure contribution. Second, each gas contributes its own partial pressure to the mixture. Third, the total pressure always equals the sum of all partial pressures, no exceptions. And finally, this law assumes that temperature and volume remain constant throughout. Understanding these principles will help you solve any problem involving gas mixtures with confidence.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.